Hey, good afternoon. Welcome to DEHN Protects online seminar series. We have an exciting episode to cover inspections and solving surge protection and earthing problems. This is a really important topic for our customers, and I'm really excited to get started with this seminar. I'd like to introduce myself, Mark Hendricks with DEHN Lightning Protection. My colleague Stephen Weber is running the polling questions and the seminar material. Welcome, Stephen.
Hello, thank you.
Thank you, Stephen. So this seminar is focusing on inspection topics, and we find this is especially important for customers because what we think of as earthing and bonding and lightning protection really forms a fundamental quality process to our electrical system. And when you have poor bonding and corrosion problems, it all reflects in the performance of your facility. So I'd like to open up a polling question and ask our audience, why are you in our interactive polling session? A couple of interesting answers. This actually helps us to understand the audience and reflect the content in a more interesting manner. Give Stephen a moment to get a consensus. Okay, well, looking for information. Good, everybody's excited, so good. We've got a lot of good information to talk about, good best practices and a way to pursue this topic. So let's move to our next slide. So why are we here? I mean, this is what the nature of lightning can do, and it produces an array of hidden and obvious problems. So lightning protection, earthing, and bonding are all about protecting your infrastructure and reducing the risk of fire. So a lot of our slide material is built around that. So another polling question, because we really want to make sure that this feels interactive to our audience. I'd like to ask, what constitutes the biggest loss to your facility from fire? And Stephen has the polling question open. Give everybody a moment to select what they think is their best fit answer, because this is, again, really important for us because it helps us understand the customer's viewpoint. Give it a moment to have everybody click an appropriate answer. Polling results coming in. Excellent. So it's the obviously the two biggies, the loss from death and the loss of the facility to produce revenue. Those are the obviously great answers from the audience. Appreciate that. So we'll move forward. Another question. This is really interactive today. So how often do you encounter grounding or bonding issues? This is important for us because we really want to know how this impacts your facility and your revenue and your livelihood. So a couple of times a year, between 2 and 10, or more than 10 times a year. And here in the Florida area, I get power glitches more than 10 times a year here at my house alone. So let's give the audience a moment. And we have a couple of times a year. That's probably the big answer, with some people that might be here in Florida, again, getting a lot more action. So this is really great to see this feedback from the audience. Thank you. So gives us an indication of how important this problem is for everybody. So why are inspections important? Why it is so difficult? So inspections are important because it avoids small problems from becoming large problems. That's probably one of the biggest things that helps our customers. We get used to seeing some conditions and we become complacent. So we don't think that the rubbish accumulating on the top of an electrical panel is a problem. And we see this so often. Poor housekeeping actually can obscure serious damage. Not to mention it can be a source of problems, just because you have parts that could fall into your electrical works. We take this kind of stuff for granted, and so a new set of eyes that is looking for these problems will certainly have an extra viewpoint to bring to a customer. And then, very often we just don't know what we're looking out for. So it's, I'm focusing on grounding and bonding, so I'll be looking for all that bits, whereas, most customers are focused on their facility. And so the things that are subtle are missed. And then we just don't know what the usual suspects. So when I walk into a customer facility, show me your pigtails. So show me those grounding bonding connections, and let's start evaluating that portion of your electrical system. So in our seminar today, we want to cover these really, I just want to call them the key steps. When you're walking through a site, when you're inspecting your work, these are what I would consider to be the steps. So starts with preparation. You arrive on a site, you need to make sure your customer is very clear with their expectations. We go through a very careful job site safety analysis, and we analyze personal protection, the lockout tagout, tool calibration, the things that are important for safety, because safety is key. And in this line of effort, in this line of work, there actually are numerous job hazards to consider. It's really good to start with a problem statement and define a scope of focus, sort of like an interview process with the customer, to make sure they've defined what they really see as their problems. And then we look at a site walk plan. What's our strategy? Starting from east to west, counterclockwise, top to bottom, have a strategy. Visual findings, that's where we start discovering things at the site. Quantified measurements, we're looking for the resistance and the current readings of the grounding system. And then other findings. There's miscellaneous things that you're going to see: damage, corrosion, material chemistry, loose parts. This can be very dangerous. Substandard conditions that may result. Of course, this is all interesting to discover all these things. You have to have a technical report and a remediation proposal. What are we going to do to offer some improvements for the customers? And then follow up with a long-term maintenance plan to make this entire process more automatic the next time around. And this is a real piece of what can become a long-term process improvement for the customers. So lightning basics. Okay, so we're here to inspect the lightning protection system. It's important to understand just a few key lightning basics I want to cover. This is a really great photograph that I personally like from first time I saw it was in National Geographic, but you can find it in public domain. Sycamore tree getting struck by lightning. But what's beautiful in this single image of a photograph are the other tendrils that have attached to the structures and the tree in the background that are in addition to the main lightning channel, where the most large, what we think of as the lightning stroke energy. But notice that the antennas off to the left, they picked up a tendril that is more than sufficient to cause significant electrical damage and fire inside a structure. So you don't have to be the exact main stretch. But what's really nice here is that this is a nice illustration of the step leader and the final attachment theory, that lightning charge moves, it is looking for a place to attach, and it is sending out and provoking electrical voltage gradients, electrical field in all three dimensions in a spherical manner, and provoking these tendrils. And this is what's really nice about this photograph. It shows you that step leader attachment. So the lightning basics: air termination system. This is the Ben Franklin rod. The downcomer system that brings that lightning stroke to the earth termination system. All the while you're paying attention to separation distance between the metal bodies of the lightning conduction system and your electrical apparatus. And where you cannot separate, you lightning equipotential bond to reduce side flash. And this constitutes what is considered a lightning protection system. NFPA 780, IEC 62305, they're very common denominator. This is the the 5 things to pay attention to. And this is what we'll look for to inspect to. The rolling sphere model. And basically what the theory indicates is that that lightning step leader acts like a big ball of electric charge that provokes a spherical electric field. And the tendril that connects is the main channel of the lightning stroke. But the other things around it that are provoking those small tendrils are also in that sphere of influence. If you're out on the golf course and you feel that little tingle on the back of your neck, you're sending out a tendril, and you could potentially be the winning lightning step leader. So lightning basics. The air terminal placement over a building is intended to provide a preferred attachment point to prevent lightning strikes directly into exposed equipment. If you had no lightning air terminals, lightning would randomly attach otherwise to something that looks attractive to its air terminal and that little tendril it's shooting off. And the lightning air terminal gives you a chance to safely direct that lightning away from your structure and your high value assets. And that rolling sphere illustration sort of looks like that tent canopy, almost like a blanket of coverage that you are providing over the top of your building. So we've got a great interactive polling question for the audience. I'd like to ask, why does a building with an external lightning protection air terminal system also require internal lightning protection surge protection devices? So here's some basic answers. I want to get the impression from the audience, and give us a moment to read this. Internal lightning protection protects the electric installation. Internal lightning protection is required for equipotential bonding. And the other answer is prevents surges in the power grid. So what's the audience's best understanding of why you want this? So let's see why SPDs are important. Do we have a quorum? And the results, kind of a balance between the first 2 answers. It protects the electric system and it's required for electric potential bonding. And yeah, that's actually all 3 answers are essentially correct, because it does most of all these things and much more. It actually extends the life of your equipment. It does all sorts of wonderful things for us, but actually all 3 answers are correct. And so it's a trick question. And you're going to see that I like the trick questions. So as we move forward, I've got a nice illustration that talks about the LPL rolling sphere illustrations. And what you see is that a less severe lightning environment has a larger rolling sphere, and a more severe lightning environment that might be a hospital full of babies and liquid oxygen that has a very difficult to evacuate and very high fire risk is a smaller rolling sphere. And this allows you to tailor the rolling sphere design to meet your need. And the reason this is important is in our basics, we want to understand what we're looking for at the job site. So if you're a hospital, you may have more stringent requirements than at a less severe risk application. And when we're looking and inspecting for lightning protection, we'll see this represented at our site. Preparation and planning. You get to the job site and you've missed the chance to do some reconnaissance. So what's always great is preparation. There's great online tools. You can gain some insight about the structure. You can get your site drawings in advance and study the electrical service, the building mechanics. There may be an installation of a lightning protection system. It's great to review this in advance. So there's always a great opportunity to plan and be prepared. Are your batteries fresh? Do you have a good fresh cup of coffee to be energized? That's a good one, my favorite. So preparation and planning. What functional area of a facility must be protected from lightning-induced ground potential rise? So as you're planning your site walk, what are you looking for? What functional area must be protected from lightning-induced ground potential rise? The main incoming feed, After the backup generator, the fire control systems, the chiller plant, the I/O, and data, PLC controls. What portion of your plant is that must be protected from lightning-induced ground potential rise? A little bit of a trick question again. But let's see what the viewers think is the most important aspect. And we're getting close to a quorum. The main incoming feed. Well, and this is actually it's really good the audience is sort of thinking that this is more important. It's a more popular answer. It's actually where ground potential rise is the best place to control it. But you'll find that you really want to pay attention to your earthing and bonding throughout the entire system. But for ground potential rise, it actually is very important at the main incoming feed, because that's where you'll get the largest voltages between your power and your ground. Okay, so preparation, you're planning, you're looking over your electrical diagrams, you're looking for where you want to find SPDs. The placement of surge protection devices is off. There's many guidelines for this, so it's easy to go to the IEC standards and the NFPA and the UL standards to get guidelines on where you should be looking for surge protection, lightning protection, earthing, and bonding. You're looking at the electrical diagrams for the plant in advance, and you're planning where you should see SPD devices. It'll show it on the schematics. If they're out of date, it may not show your surge protection devices, but these are the targets that you'll be looking for in your planning. So it's good to understand what the overview of the site is. It's not always possible, but this is part of your planning. Okay, so we're talking about inspections. So interactive polling question, what is experience? The accumulated wisdom that comes with time. Or is it B, the one thing you need 1 second after you need it? And let's see what our audience thinks about this sort of side of the psychology. The polling results are, it's the accumulated wisdom. Yeah, that's a great definition. That's what I like that one. A safety instructor told us in a site review one time as we were getting ready to do our safety analysis. He reminded us that experience is that one thing you need 1 second after an accident occurs, and so that's where you gain experience. Interesting to see that side of, and that's why safety is a paramount issue. So in our process, we always make sure that we attend to safety. Is there a safety review for the site? What do we expect to see? Are we at a plant that has moving conveyors that at any moment could have moving objects? Of course, we're looking at electrical panels. We're probably doing non-invasive activity, but we're still subject to electrical arc flash possible. We're looking at high temperatures. We're looking at chemicals. You're seeing corrosives, biological. One of my favorites you'll see is insects, radiation. You could be here in South Florida and it's the sun's rays that cause significant dehydration at a job site. So it's really important to understand your safety analysis, and then to do it as part of this analysis with your customer, understand their description of the problem. So that's why we have an interview process, so that we can understand their expectations. And it's really part of the interactive arrival and preparation at your job site. So a problem statement. What is their expectation? Are we going to be protecting from direct strikes? Are we looking for problems that might be related to indirect problems, indirect strike effects, where it's affecting the electrical apparatus? So it's good to understand their expectation. So as we're getting ready to run the site, it's really excellent time to do a site plot plan review. Have an inspection plan. Have a survey route so that you can follow a very logical path. I like to start at the main service entrance electrical disconnects and work clockwise around the plant. It just makes it really easy to follow your inspection notes, and it makes it very easy to follow the survey route. And it's just part of the planning. And then when you come back and For instance, here you see we've input the measured values for earthing, pigtail, impedance, and resistance around the plant. It's really great to have that as a fallback because now you can provide the customer more comprehensive data. Site plot plan review. This is part of the what to look for. So external LPS is not required because here's some interesting answers that I get from customers. The LPS attracts lightning to my building and I don't want it. The LPS is too expensive. I already have surge protection on my power, on my AC service entrance. The LPS is not in my specification. It's common. That's who needs it. Or the LPS is required for my building. So that's, in fact, you understand that the customer does want this in their structure. So let's see what our polling answers are today. Getting a quorum, and most people actually do require it. But you see this mix. If it's not required, why do I need it? And that's a really big, it's a really big issue. So, you know, our intent is to make sure that we understand why we need it and then follow up with what is in fact specified. So visual findings. Now you're on the site. You know what you're looking for. You're spotting your lightning protection system. This is some of the products that are considered non-conventional LPS systems. They're not recognized by NFPA 780 or the standard IEC 62305 specifications. They're considered non-conventional. This particular device might claim that it has an extended step leader reception capability. That actually has been debunked by a considerably large volume of a body of work from such experts as Anton Raycab and Uma Martin. And these types of apparatus have been proven to be no more effective than an actual lightning air Franklin rod air terminal. So what you might find is that the customer has this type of device installed, but if you apply conventional principles, you will find that it doesn't cover the entire structure and in fact can leave some areas exposed. As I said, there's a considerable body of work talking about non-conventional systems. I encourage the participants to follow up on. So back to that discussion then. Here's a polling question to make sure we've talked about this. The rolling sphere radius represents 3 answers, possible answers. And you know I like the trick questions. The theoretical attachment point for a step leader, the distance a step leader can jump, or is it the coverage calculation over a structure? So what does that rolling sphere radius represent? What's the common answer for today's session? Well, the coverage over the structure. It's actually all 3. So again, trick question, but it's really a matter of perspective. How are you looking at it? So we like to show the customer the coverage calculation over a structure because that's the way to visualize what their benefit is. So it's really a way it gives me an understanding of what our audience today considers most important. Visual findings, conventional equipotential bonded LPS systems using the fuzzy tips. This is some sites that I've recently seen. This is in fact a conventional equipotential bonded lightning protection system. And you can see a fuzzy brush air terminal. It's got a dedicated bonding down conductor that takes it around the side of the building to earth. But there's, notice in this one photograph, there's actually at least 2 other tips that are broken away. Here you see that elbow joint, but the missing fuzzy brush. And here the entire elbow joint has been separated, sheared away, and then the downcomer is actually hanging loose. That's actually a bit of a problem there because now you have some unbonded metal components that are going to possibly arc and spark. The difficulty with a system like this, I've actually, as I said, I was inspecting a site like this, and these apparatus are very robust. That's actually a very strong joint. So there's been considerable damage to cause this to be broken away. This was not a trivial, just a pleasant breeze that caused that to break away. So there's been some considerable damage to this site to cause this much physical problem. So isolated lightning protection. We've seen two conditions where we're looking at what looks like equipotential bonded lightning protection. But what does isolated lightning protection prevent? Isolated lightning prevents side flash from down conductors into an adjacent structure. Does it prevent ground potential rise at the master bar from other nearby earth rods? Does it prevent ignition sources from sparks between unbonded metal? What does isolated lightning protection prevent? So when you're at a site and you see these types of systems, what was it there for? And it helps you understand the value of the system. The polling results are sort of a mix between side flash and sparks, which, again, you like my trick questions. It does all three of these things. It's just again, it's understanding what the customer's perspective should be. So a customer that's highly motivated to have the safest system is going to have something like an isolated lightning protection system. Here's a nice Google image of Launch Complex 40, and this is near where SpaceX is conducting their launches. And it's very easy to see these extremely tall towers around the launch platform. And this customer is extremely motivated to prevent any lightning risk onto their launch vehicle prior to launch. We've got a vehicle highly exposed on a platform, and it's full of rocket fuel, ready to launch and explode. And a lightning strike is the last thing that this customer wants to see. So they have an extensive isolated system where it will prevent any lightning from direct strike, and it will prevent side flash, and it will prevent ground potential rise. So the customers that are the most motivated will employ something that looks like an isolated air terminal system. And this is important in your inspection process to recognize this and then notate it correctly. So we're moving on to an extremely popular technical aspect. What does the loop reading on a clamp-on meter show? And you know my affinity for trick questions. It provides a resistance of a loop. It indicates below ground connections that you can't otherwise see visually. It shows the existence of a loop. It allows you to evaluate if bonding connections are good or bad. And it shows the resistance of the ground system. Now, this is a really important trick question. So I'd like to see what the audience thinks that the meter gives them. What does that tool do for you? So let's see what our audience thinks. Polling question coming up to a consensus. We've got a little bit of a mix in what the audience considers the value. What does it show? Well, it shows you most of the first four things, but it actually does not show you the resistance of the grounding system. It's only measuring that one pigtail that you've clamped onto. So what's really interesting about this answer is that we wish we could see the resistance of the entire system, but that's not what a clamp-on meter will show you. So I'd like to move on and show some really important basics. So a clamp-on meter looks like that top graphic. You're measuring one pigtail and you're looking for a loop. And what it does is it sends out an active clamp-on meter, sends out a sonar ping, and then senses the return signal. And what it actually sees is everything relative to its contribution. So you're seeing the one pigtail loop, but it senses all of that buried resistance of these unconnected resistances through these other earth terminals. And the reading might be high and maybe in the 12 ohm range, or it might be small, depending on what's buried. But what's important to understand is it doesn't tell you the entire system. It only looks at that one pigtail. So this is where it's very important to understand what you're evaluating. It gives you an indication, but in of itself, it is not a pass-fail unless you know what you're looking for. So if I know I'm looking for a buried connection, and if I know that I should be connected to buried rings, I should get a 0.69, a 0.64 reading. If I'm actually measuring earth rods that I know are not connected with a buried connection, then a 12 ohm reading actually is okay. So it's important to know what you're actually looking for. And with this meter, you can inspect and you can detect what you think is there and then deduce what might be part of the buried ring. So it's important to understand that it has limitations, but it's a tool that allows you to deduce what's buried. What is buried? So here I've got an example where I measured a very low value of 0.062 around the structure. And I knew I was looking for a buried ring, but I found a 19 ohm pigtail. 19 ohms will tell me that that pigtail is not like the rest. And I can deduce that I had a problem with the buried ring. The customer had to excavate and repair a buried connection. And this is important to understand. What do you expect to see? What do the rest of the measurements look like? And then it allows you to evaluate the difference. Now, this slide's got a lot of information, and I can move really fast because it's really for background. But the most important thing is to look for soil resistivity and ground loop measurements. If you actually need to understand what the ground resistance of the grounding system is, you have to look at each individual earthing rod. You have to look at it relative to a fall of potential across the soil where you're near, and then you have to combine that with all of the rest of the individual earthing rods. So the time to evaluate a ground resistivity of your grounding system is when each rod is buried, but before they're interconnected. And so the reason I use this slide is because it really helps you understand that it's the soil resistivity and the fall of potential. That's the piece that helps you understand the larger earth resistivity of the entire site. Visual findings: lightning equipotential bonding, metal to metal, and surge protection. So wherever possible, for instance, in copper water pipes or in black gas pipes, you're bonding the metal to metal. But what you find is that electrical surge protection is used to bond the equipotential voltage of conductors. So you can't bond it, but you can control the voltage. And that's what that SPD is intended to offer right here on that main AC power. You have your ground is bonded, your green, yellow ground, but the SPD provides a voltage control for what you cannot bond. So, visual findings. Why is earthing so important? Well, you can see in this photograph above that there's a grounding return current that is so high that it causes considerable safety hazard. And what's happening right here in that conductor is that so much ground current is flowing that it's causing the fastener to glow cherry hot. That's extreme safety hazard. And it's a lesson to provide the inspector experience that you don't just go in and start touching some of these apparatus. Never touch those connections directly. Speak softly and carry a wooden stick, because you don't want to be the one that's touching that stuff directly. I often do exactly that. I'll carry a small stick and I can bang on things and look for loose connections, because if you touch those loose connections and there's currents, you will feel it, and that's a safety hazard. So it's really important to understand how dangerous this can actually be. So here's a nice illustration of what looks like extremely well connected and best practices. Poor practices, best practice. It's good to understand the difference. Visual findings. You often see pigtails emerge directly out of the concrete, and there actually are IEC standards that describe specifically that conductors should have a covering. Like you often see a vinyl coated conductor emerge through the concrete. This is a little bit substandard here. You've got oxidation on the lugs. You've got a single hole ground lug that can spin loose. So it's good to understand that grounding anomalies can be direct result of the installation. So it's really important to understand what you're looking at. Buried connections that are already buried, you won't be able to come back and see them later, but it's nice to understand what might be below grade. So you can't inspect it directly, but you can measure it with your clamp-on meter to see what might be there. Good indications of what the installed solution should look like. There's suitable materials to prevent corrosion for buried connections. It's good to understand the grounding basics. This is what you don't see anymore. It's already been buried. But what's buried? What should it look like below grade? What can you visualize? So you might have your customer drawings and they indicate that there's a buried ground ring. And so this is what you cannot see, but it's important to understand what it should be. And so these photographs and illustrations are important to show you what to expect below grade and what some of these finished installations should look like. Visual finding, damage to pigtails. This is my #1 culprit to look for. Show me the pigtails. You've got kinks in the wire, you've got broken strands. Here we've got illustrations, photographs showing broken connections, unbonded metal with this now hanging loose in the water as a arc and spark damage risk. So this is the type of things we're looking for. This is the my #1 thing. Show me the pigtails. Okay, visual findings, interactive polling question. From what type of equipment should the separation of the down conductor be maintained? This is sort of a trick question, so I want to understand what the customers and the audience thinks. Where should separation be maintained? From buildings, from trees, conductive parts, mounted structures, interior installations. What does our audience think is the answer to my latest trick question? We're waiting for here we get a bit of a consensus. Conductive parts. Well, you know me with my trick questions. It's actually most everything, but it is that C is actually a right answer. But we're actually protecting from almost everything around it. Separation distance is to electrical metal parts, but you've got to keep your spacing between everything. So this is really an interesting answer to that question. So let's move forward. Visual findings. Housekeeping. I can't stress this more for my customers, is to maintain proper housekeeping. And this was one of my favorites. My colleagues will tell you that I do not like wasps. Having been stung plenty of times, I'm not personally allergic, but it's still not very fun. So when you're inspecting a site, you can't let the wasp chase you away, but you still gotta behave safely. So in this one photograph, I can see several things that might be wrong, but the poor housekeeping sort of obscures a lot of the problems that you might see at a site. So this is a really good reminder to help your customers understand that a clean, well-connected site is going to be your best friend over time. Lack of SPDs is going to be a major concern. It's really hard to tell, but there does not appear to be any sort of equipotential bond on that metal panel. Oh, and did I mention that it's full of wasps? My favorite. Here we have another green wire. I don't even see that because all I saw was wasp, then it chased me away. So again, housekeeping and control of your insect population. It's really hard to run a proper inspection when it's a safety hazard. Okay, interactive polling question. And I've got a nice photograph to point out to illustrate the point. Why is a broken pigtail really such a big deal? Why is it so dangerous? Well, it could spark when it's reconnected. That could actually be a return current that's waiting to reestablish. An unknown current could flow when it's reconnected. Unbonded equipment will experience a voltage gradient. And it could be a static or spark source. Which one is, why is it so dangerous? Well, I have my own view. What does our audience think is the most dangerous part of that? Polling question, kind of a toss-up between unbonded experience of voltage gradient. It's actually all four of them, but there's sort of a what's the most dangerous is still it depends on your customer application. If this unbonded pigtail is in an explosive environment, say next to a gasoline station pump, and that spark occurs, that is in a class 1 div 2 environment, you've got an ignition source. If it's in an electrical panel and you're at a transformer disconnect and you have a loose pigtail, I can promise you there are grounding currents flowing. And when you touch that, you're going to feel that grounding current. So it really depends on where we're at and what the customer feels the most dangerous portion is. So this is good to understand the customer's experience. So we'll move on. We've got another polling question. Excellent. And we're moving on to surge protection devices. Provides what? Surge protection provides. Now, I know I've cheated and talked about this a little bit, but what is it the best description? Is it the equipotential bonding for electrical wires to ground, voltage control between wires, a surge current path to get that surge current to ground, voltage relief, sort of like a pressure valve during transient events, or as my salespeople like to point out, no value at all if it's not installed. What does my customer base think it's the most appropriate answer? Waiting for a consensus, and it looks like a surge current path to ground. It's actually all of the above, and my salespeople will tell you it's actually the most important one is number E, but you're getting a trend to my question process. I'd like to give the customers a lot of options to see what's most important to them. So a surge current path to ground, it's actually, they're all true. So it's just interesting to see that what the philosophy of the customers. So as we're moving forward, visual findings of SPDs. I've seen some terrible stuff. I can assure you that it's hard to surprise me anymore, but every once in a while, why is it glowing incandescently hot? That's a problem. There's clearly something wrong with so much current flowing that it's melting the wire. There's numerous things that we see that go wrong. People apply what I call daisy chains, loops, everything. When it comes to bonding, everything should have what I call a home run back to the master star node. So in an electrical panel, something that looks like this green wire going to this surge protector, green wire for this surge protector, it's sort of like a big loop in there. And that's not actually best practices. It's connected and it works, but when there's a surge event or any sort of other transient that might cause disruption, it causes more havoc than it solves by having all these loops. What are we looking for? Visual findings. This is what we're looking for. We're looking for the application of surge devices. We're looking for the position near the point of use, short connection wires, avoiding tight bend radius, using the largest, heaviest gauge wire practical, direct connections to the earthing bar. These are the things we're looking for. So when you see it, you recognize it. We've got some really great illustrations of what to look for. Clean electrical wiring, easy to identify components, good earthing lug right down there in that lower right-hand corner of the panel. But there's some red flags. No SPDs on the AC power. Missing a bond for dead front doors. These are the things that we're looking for. Those are some indications of red flags that the customer will have to come back and offer remediation. So You might be impressed by the cleanliness, it's such a nice layout of the cabinet, but it doesn't have key functions. Visual findings at the control centers. Again, we're looking for those same types of things. There's a lot of equipment in here that can suffer electrical damage. We're looking for AC surge protection. We're looking for SPDs on the emergency lighting circuits. We're looking for SPDs on the IO lines, the control lines, so that this operation is robust and can withstand lightning damage events. Visual finding, bulletproof protection on both ends. It's really important to understand that a surge protection device needs to be installed if the distance between the source and the equipment is more than 10 meters. And so significant currents and voltages can develop over that distance, and it's important to have surge protection devices on power over Ethernet and different IO control circuits at both ends. So this is something that we're looking for. Visual findings. We're looking for things at the flow meters. We're looking for good bonding of the SPD. We're looking for devices that are, proper treatment of the shield wires and close to the point of use. So these are the things we're looking for best practice. Here you can see the surge protection device is installed directly at that flow meter for best point of use control. Visual findings, other types of things that go wrong, corrosion of galvanized materials remember we talked about where the conductor emerges from the soil as a point of protection. Well, over time, this one corroded to the point where when we hit it with the stick, it broke loose. And that's a major problem. That could have been a transformer bond, and you don't know now that the transformer could be floating. That could be a really big electrical problem. So these types of things that just go wrong over time. It's just maintenance and wear and tear over time. Visual findings, grounding anomalies, broken pigtails, poor housekeeping that obscures the connections, makes it hard to trace because you just can't really see everything clearly. Broken pigtail connections. Show me the pigtails. These are the things that we're looking for. This is what goes wrong. This is what to look for. Multiple bonds under one lug of dissimilar metal sizes. Broken pigtail connections off here to the other side at this bonding point. So there's methods to repair this that will improve the overall site and reduce what I'd like to call daisy chain connections. Multiple wire sizes over one pigtail that emerges directly from a concrete without connections, without protection over that conductor. Bonding connections that are hanging loose. So now you've got, again, the potential that earthing faults are not protected. When you touch this motor housing, there could be an earthing fault, and there could be earth currents flowing that pose a safety hazard. Good practice. It's always important to understand what good should look like. And here you can see some good practices. Here's the electrical wire emergence from the soil. It's got a sheath. It's protected along the rise over the exposed concrete. Good exothermic weld onto the steel I-beam. Technical reports and remediation. So you've done a site inspection. You've got all these great notes and photographs and measurements. It's important to give the customer a concise review and a concise scope of work. You need to repair this material. You need to install these SPDs. It's very important because now you've shown him what's wrong, and you want to show this customer what to do to fix their problems. And this is where it's really important to understand the application of surge protection devices, the application of additional bonding, the application of surge protection next to motor control centers, the application of point-to-point bonding. So you can see that each one of these pieces of the variable speed drives have their own returns back to the electrical bonds. So this is just a nice sort of checklist for yourself. Are there SPDs on the emergency safety interlocks, on the emergency light systems, on the SPDs on coaxial radio antennas, direct connection to earth? These are the things we're looking for. That should be part of your findings. And then the selection of proper surge protection devices based on the electrical apparatus in front of the fuse panels, directly at the point of use. It's really important to understand that the electrical panels are properly protected. And then pretty much in closing, we just like to make sure that the customers have a good long-term maintenance plan. Facility drawings should be updated for as-built conditions. You want to perform an LPS inspection every 2 years. The inspections from such agencies as Underwriters Laboratory or Lightning Protection Institute, those inspections are valid for 2 years. So it's important to come back. The apparatus are generally very robust, but they are subject to wear and tear. And it's really good to maintain proper housekeeping. It just simplifies all of your other operations and maintenance functions. So I'd like to also ask the audience an opportunity to answer one last polling question as the seminar concludes. We also want to open the field to any questions that might have come in from the audience during the session. We've got a few minutes. Stephen, did we receive any important questions today?
Yes, thank you, Mark. I just want to elaborate a bit. At the end of the webinar, there will be a survey question that Mark is referring to that's going to pop up, and if you can just answer that as the last and final question. So we have a question. He's asking, in an industrial facility, Mark, are you testing all of the pigtails that you come across, which can be quite a lot, or do you actually only consider pigtails that connect to MC, motor control rooms and those places?
That's actually a really great question, and this goes back to the preparation with your customer. Is your inspection comprehensive? And an industrial facility, Stephen and I have done some, and yeah, you're talking about hundreds of measurements. So this is obviously things that'll take significantly more time because every scientific measurement, properly calibrated, takes a few minutes of time. So you can do the math. 100 measurements could take you several days to conduct. Is it a spot check? It's exactly what's important to understand with your customer. So yeah, you can go to the critical areas like transformers and part of the lightning protection system itself and just keep it focused. Or you can be 100% comprehensive across the site. I've seen customers and they want both. So they want a complete site map with every measurement made at the end of it, and it's an important piece for their long-term maintenance plan. Again, what's their expectation? And it lets you set the scope of the work and the actual inspection. So you have enough time. That's a great question.
Thank you, Mark. And then a question, when you're conducting these inspections, what is your comment on exothermal connection of pigtails versus mechanical connections?
So it really goes back to, there's a couple of philosophies on it. For instance, the IEC methods indicate that you really want to be able to separate the connection and do individual maintenance inspections. So one of the questions we get asked all the time is, does my earthing system meet my spec? I have customers that have a 1 ohm earth grid system, but that doesn't mean that each lightning earthing rod is 1 ohm. And the only way to prove that earthing rod meets its requirement is to separate it from the rest of its friends and measure it individually with the follow potential. This can become prohibitively difficult on a big concrete site. And so some customers say, well, I'm never going to separate them, so exothermic welds are the way to go. And I have other customers that say, I want to be able to separate them someday, do individual measurements. And so different connection methods are the way to go. And I see them all, and it really becomes a philosophical question. I'm not sure, Stephen, if you've got other insight.
No, I agree, Mark. And I just want to add that, remember, in doing these inspections, it's important that you also look at the exothermic weld connections themselves as well, because we have come across some really bad exothermic weld connections where certain strands were already damaged due to corrosion, whatever the case may be. So in your inspection plan, make sure that you also address and make sure that those exothermic welding connections are properly done and they are still in a good condition. And in the case of mechanical connections, feel and tug on the wire a little bit, and like Mark said, make sure that that mechanical connection is still properly on there. And sometimes when we do these inspections, we grab a wrench and we just retighten, things that we feel just could be addressed by just retightening it. Mark, the next question is regarding SPDs. He's saying that you're conducting SPD and inspection of SPDs as part of your inspection program, but is there a way in which you can actually test an SPD, or how can you determine if the SPD is still in a functional condition?
It's a great question, because SPDs actually don't necessarily last forever. A lot of the DEHN product have built-in enunciation features. We have very clever products that for the data line protection that have a very clever way to monitor how much life they think they have left. Are they approaching end of life? So there are products and there are ways to monitor in situation, in field, if it's still working correctly to its specification. For an AC powered surge protection device, the only way to know for sure is to remove it from the AC service, get it on a bench, and apply a particular voltage control and current limited power supply, and measure the device and see if it's still within its manufacturer's spec. It still doesn't tell you if it's got much longer to live, but it tells you if it's within its manufacturer's recommendations. And what I found is the only way to do that is to pull it out of service, put it on a bench with a power supply, an appropriate voltage source with current limit power source, because you want to drive the SPD into its performance. That's really the best methods I've encountered.
Yes, and it just emphasizes, and I just want to say, it just emphasizes the reason why you want to go for an SPD that has a visual indication to tell you if it's damaged or not. Some of them have a floating contact that you can wire into a control system that tells you if it's been damaged. Or in the case of control SPDs where you don't necessarily have a visual indication, you get SPDs that have a internal RF communication module that you can literally put a tester on and see, and the tester will basically tell you if the SPD. So you do get different technologies out there that that addresses the way in which SPDs can indicate if they are still in their useful life or not. I don't know if you want to add something to that.
Nope,
Mark.
that's excellent.
Okay, I think that's all we have time for.
Yeah.
Thank you, Mark, for the webinar. Thank you, everybody, for attending. We'll have a recording of this webinar on our DEHN USA YouTube channel, so you can go there, you can share that, and if you have any further questions, you can just send me an email and we'll make sure to address it with you guys. Thank you.
Excellent. And be sure to answer our polling question. Thank you.